Okay, we are going to be dividing rational expressions. So naturally, following our pattern, we're going to start dividing rational numbers. So what we're going to be doing here is we are going to be switching this division of a fraction into a multiplication of a fraction. So I'm going to take 45 over 4, and instead of dividing it by 9 over 2, I'm going to multiply by the reciprocal, because that's what we've done all along. So I've changed a division question into a multiplication question, something that I've done before. So I stop and I take a look and I consider these numbers and maybe what's common factors. And I recognize that 45 can be written as 9 times 5. I do that because it's important, because I have a factor of 9 in the bottom over there. So that's 45 over 4. But instead of 4, I'm probably going to write it as 2 times 2. You can do the prime factorization of this by any means. Yeah. So this is 2 over 9. And what I'm able to recognize is that in this multiplication, what I have is a common factor of 9 in both the numerator and denominator. Those are the factor pairs. In the numerator and denominator, I have a common factor of 2. So 45 over 4 divided by 9 over 2 can be simplified into, I have a factor of 5 in the bottom, factor of 2. So 5 over 2. Wow, that was pretty straightforward. Now, I believe in our next example, it is 1/2 divided by 1/8. Now, I'm not using a division symbol, but I am using it in it's a rational number divided by a rational number. So I'm going to take my divisor, and my divisor here is 1/8. I'm going to multiply by the reciprocal of that. So what we would do very simply is take 1/2. And what's the reciprocal of 1/8? It's 8. And fair enough, right? So I have 1/2 times 8, but I recognize 8 has a factor of 2. So I recognize that both top and bottom, well, you might say, hey, there is no denominator. Just made it so. We have a factor pair of 2. So I'm going to cancel out that common factor, and I'm left with 1 times 4 is 4. And my denominator is 1. But I'm just going to leave it as 4, because when a number, anything that is expressed over 1, we just simply get rid of the denominator of 1. It doesn't make sense. So the answer is 4. This next example here, so I'm just going to maybe, just maybe, look at this. So I know that, thinking of right away, I have 2 denominators, and that is y cannot be equal to 0. Fair enough. So that is my restricted value, right? Because it's a rational expression. And suddenly, when I change this into a multiplication by multiplying by the reciprocal, I have to be careful, because all of a sudden I have the variable x as a denominator when I take or multiply by the reciprocal. So I also have to say x cannot be equal to 0. So really, y can't be equal to 0, x can't be equal to 0. So now I need to start looking at my factors. So I'm going to take a look and consider. And I'm just going to write this as 3x over 2y times 2 times 2y over 3 times 3x, 9x. I'm going to cross out common factors of 3, cross out common factors of 2. Hey, that was straightforward. I'm going to reassess the situation. I have a common factor of x that I can cancel out. And take a look at the denominator. I have a factor of y, and the numerator has a factor of y. So that was a lot of factors I was able to cancel out. What I get is this expression is 2 over 3. However, x comma y cannot be equal to 0. Huh. Interesting. So the process. That's right. Everybody's favorite word, factor. We're going to factor both numerator and denominator. We are going to identify the non-permissible values. We're going to multiply by the reciprocal of the divisor, exactly what you would do with fractions. And then we're going to revisit the non-permissible values. We're going to express the numerator and denominators of the products as a product of factors. And then we're going to eliminate common factor pairs among the numerator and denominator. So really, we're just going to change the question into a multiplication, but paying very close attention to the non-permissible values. Just in case you thought there couldn't be more factoring. Good news, there's plenty. So if you want to start off with this expression here, you can press pause and start factoring. So if I start factoring the maybe I shouldn't start factoring. Okay, sure, why not? I can factor the top, factor the bottom. I can say that this is divided by, factor the numerator of the divisor, and I can factor the denominator of the divisor. Wow, that was certainly a lot of factoring. Not hard, just a lot of it. So I'm going to pick off my non-permissible values, which there are plenty. So what I have is x cannot be equal to 0. X cannot be equal to 4. X cannot be equal to -5. Now, if you notice, this is the same factor if we had this factor before. So those are my non-permissible values. I'm going to rewrite this division as a product. So I have x minus 2 times x plus 2 divided by x minus 4. I'm going to multiply by the reciprocal now, which is, x plus 5, x minus 4, divided by x plus 3, x minus 2. To go from this step to that step, it would just really multiply by the reciprocal of the second rational expression. So I asked myself, have there been any new non-permissible values? Sure. I guess x cannot be equal to -3. Similarly, x cannot be equal to 2. Wow, there's certainly a lot. I feel now I'm able to cancel out common factors. I have a factor of x minus 2 in the top and bottom. Cancel out. I have a factor of x minus 4 in both top and bottom. So I cancel out. Is there any other pairs among the numerator and denominator that are the same? And in fact, no. So the numerator, I could write it as x plus 2 times x plus 5. Those are the two factors that were not canceled out. In the denominator, I could write it as x and x plus 3. Keep in mind, I'm just going to put that those are my non-permissible values. So I'm hoping to do something a little bit more difficult now. But it's going to be the same. I'm pretty sure it's going to be the same. So what I'm going to do is I'm going to factor the top. I'm going to call this term the yellow term, and this term the green term, and this one the pink. Well, there's 3 separate terms now. Like it's kind of getting a little bit crazy here. So I'm going to factor the numerator of the yellow term. And if I do that, I believe it's 2m minus 5, let's see, plus 3. I believe that's correct. Now I'm going to factor the denominator of the yellow term. So it has a common factor of 2m, so I factor that out, and I'm left with m minus 5. That shouldn't be a surprise, right? Because we are indeed, we do have a common factor, m minus 5. Now I'm going to factor out the numerator of the green term, and that's wonderful because it's a difference of squares. 4m squared minus 9m is a difference of squares, so there it is. And the divisor is 6. I'm going to multiply it by 3 minus 2m. Now, I'm just going to put that in brackets. I made one small mistake. I'm going to fix it right away. This was actually a division. So my non-permissible values, m cannot be equal to 0 and 5. From the yellow and the pink factors, respectively. I'm going to rewrite my division as a multiplication by multiplying by the reciprocal of the divisor. So 2m plus 3, m minus 5, divided by 2m, m minus 5, divided by, so now I'm going to take the reciprocal of it and change this into a product. So 6 over 2, sorry, this should have been m minus 3, two m plus 3 times 3 minus 2m. Now, I get the nagging feeling that I've seen this somewhere before. But maybe let's simplify and we can circle back. Let's get rid of some of the thoughts. So I have a factor of m plus 3, so I'm just going to cancel those out. I have a factor of m minus 5, going to cancel those out. So I'm going to rewrite this as 6 times 3 minus 2m divided by 2m minus 3. I recognize that my factor 3m minus 2 and 2m minus 3 are additive inverses. So I could move along. Give me 1 second. So I have 6, 3m minus 2, 3m minus 2. Oh, I forgot a factor of 2m over there. Okay, so factor of 2m. Yes, and I think I have all the factors. Okay, so now I have all the factors. So I'm going to revisit this. Do I have all my non-permissible values? Well, in fact, I missed 2 right there. So m cannot be equal to 2 over 3 or negative 2 over 3 as well. You always have to keep in mind, revisit what values of my variable make my denominator 0. Oh, I notice that 6 can be thought of as 2 times 3. I also noticed that this and this are additive inverses. So if I just factor out negative 1 from 3 minus 2m, it changes to 2m minus 3. I'm going to divide this by 2m and 2m minus 3. It might help if I just put my numbers in brackets. Is that better? So I have a factor of 2 in both top and bottom. Cancel each other out. Now I have a factor of 2m minus 3 that I can cancel out. What factors are left in the top? 3 times negative 1. And that is better known as, you could leave it at that. It's in factored form. Negative 3 over m. Wasn't that absolutely crazy? That big expression simplified into negative 3 divided by m.